All right, let's do an example. This is from 6.775 on maximizing profit. And I just took one and I had to redo it because when I started to redo it for you guys, it changed all the numbers. And I wanted to, anyway, I wanted to go ahead and have it set up. It takes Fina tailoring 3 hours of cutting and 6 hours of sewing to make an organza bridal dress. It takes 6 hours of cutting and 3 hours of sewing to make a lace bridal dress. The shop has at most 24 hours per week for cutting and at most 30 hours for sewing. The profit is $318 on an organza dress and $270 on a lace dress. So, how many of each dress should be made to maximize profit? And I guess they'd probably also ask on MyMathLab, what is that maximum profit? So, we're going to set this up real quick. So what I did is I came over here and I started to make a little chart. And you can see I had to wipe this out. But to kind of organize this. So I knew I had two types of dresses here. So I did this. I knew we were talking about cutting and sewing. And on the first dress, it told me that there were 3 hours. It took 3 hours. What did it say? Yeah, 3 hours of cutting. I was looking over there to see what it said. I'm looking right here. It took 3 hours of cutting, 6 hours of sewing. So that's what I did here. 3 hours of cutting, 6 hours of sewing. And then on the lace dress, it was just the opposite. It took me 6 hours for cutting and 3 hours of sewing. So I did that. So I set that up like that. Then notice what it said here. It says the shop has at most 24 hours per week for cutting. So right here under cutting, I knew I had at most 24 hours. And then it also said I had at most 30 hours for sewing. Now, I'm going to make my profit for each organza dress was $318. So I stuck this over here under profit. And for my lace, it's $270. Now, you do not need to do this, but if this helps you to organize, then great. Okay? Now, I'm going to let this represent my organza dress. I'm going to let it represent my X's, and my lace is going to be my Y's. So I'm going to organize it this way. So I'm going to write out my equations. So notice here, my first equation is it takes me 3 hours of cutting for every organza. It takes me 6 hours of cutting for every lace dress. And I only have at most 24 hours. So I know this has to be less than or equal to 24. So that would be one of my equations. So I'm going to keep all of this grouped together. I'm going to do the same thing here. It takes me 6 hours of sewing for an organza dress and 3 hours of sewing for a lace dress. And I have at most 30 hours. Okay, so there would be another equation. Now, I'm going to graph these two, but what you also need to realize is that no matter what, I am going to make at least none, or at least it's going to be a positive number of organza dresses. I'm not going to make a negative value, and I'm also going to be, that's true for my lace. So I've got 4 equations here that I'm going to graph. Okay, so let's just graph this one first. Who cares which one you graph first? So I would come down here, and there's several ways to graph. My favorite way on this one is to get the y by itself, so it's in slope-intercept form. So if I do that, I'm going to move this 3x to the other side. I've got this. It's a positive on this side. When you move it to the other side, it's negative. I would divide everything by 6. And so I've got here is y is less than or equal to negative 1/2 x plus 4. Now remember, if you're graphing this, this is your y-intercept. That's where it hits the y-axis. This right here is my slope. Okay, so just in case you forget how to graph. If you were on MyMathLab, and I'll do one here for a little bit when you're graphing, that would be an easy point, is to click right there on 0, 4, which you can see, which is what I went ahead and did. So I would just save a little time here on the video. And then because my slope is negative 1/2, I went up 1 and then to the left 2. So I could do that again, up 1 and then to the left 2. You can also go down 1 and to the right 2, but I know it's negative slope, so it wants to look like this. So that's going to be the graph of my first line. Because it's also or equal to, I'm going to draw a line through this, and I'm trying to decide how to do this while looking through my phone. So give me a second here. And I am looking through my phone, so it's going to be kind of shaky. Okay, so something like that. I'm just going to sketch it out. It's going to be kind of rough. Now, I have to shade this, so pick any point out here in space, not on your line, to plug it in and try to see if it works. And I would try 0, 0 just because it's easy. Notice in my original equation, if I put 0 in here and 0 in here, I get 0 plus 0. That is indeed less than 24. So this point, which was below the line, did work. So I would be shading everything in below this line. I'm just going to do it real light. Okay, so this is just kind of for me. So there we go. I'm going to shade all that in below the line. So there's 1. Okay. Now I'm going to do that same thing for this line. So I'm going to come over here. Let's see here. And I'm going to get the y by itself. So I'm going to move the 6x to the other side. So remember, when you move it to the other side, it changes signs. Divide everything by 3. And luckily, these numbers are coming out pretty. 6 over 3 is 2, so I have a negative 2x plus 10. So this right here is my y-intercept. So I'm going to go make a point on the y-intercept. This is my slope, which remember, my slope is rise over run. So I just made that into a fraction. So I'm going to come up here to 10, and it's going to be up 2 over 1 since it's negative, but I'm going to go down 2 to the right one because I'm out of room. So I've got something like this. Let's see, down 2 over 1, down 2 over 1, something like that. And then we're going to draw a line. Whoops. Down 2 over 1, something like that. It's pretty shaky, I know. That's what I get for looking through it. Okay, again, this was I don't have that shaded in very good from before. I want to know this is less than or equal to, so I'd pick any point below this line. Again, I would try 0, 0, since it's not, going through that point. Why not? It's an easy point to plug in. So I plug in 0, 0, and I see if it's true or false. So I'm plugging in 0 for x and 0 for y. And that is less than 30. So that was a point below the line, and it worked. So that means anything below this, I would shade in. But the goal here is to find out where they would both intersect. So obviously it's not intersecting up here. So I'm intersecting down here. So it's everything down here below this line. Okay, so far this is what I've got. Now my other one should be easier to graph. Okay, so I'm all in here. Because this wants all values of x greater than or equal to 0. Well, that would be right in here. This is your line, x is equal to 0, right there. So I want everything greater than that, which would be to the right. So I've got all of this. And at the same time, I want everything greater than y. So what I've got is this little box in here, okay? That's the only thing that should be shaded. So if I was graphing this in MyMathLab, which you don't have to on these type of problems, I would want to make sure that this is not shaded in, only this little box right here. These are my vertices right here. I've got 4 vertices. So I've got the point 0, 4 is what that point is. I'm going to write that down. In fact, I'm going to do it down here. I've got the point 0, 4. I had the point 0, 0. I had the point 1, 2, 3, 4, 5, 0. And this point of intersection, which I can see on my graph, is 4, 2. Now, here's the deal. If you cannot see that point because your graph is kind of rough, and, what I would do is if you solve these, pretend these are equal sign and solve them, you can use the Gaussian elimination method, or you could just use any method to solve these two equations to see where is that one point where they intersect. So, for example, I could multiply all of this by -2, so that when I add straight down, things cancel. But these are my 4 points of intersection, and it wants me to maximize my profit. Now, this is where this comes in handy. I know that my maximum, to get my profit, I'm going to make $318 for every organza dress. Remember, I let X be my organza. And I'm going to make $270 for my lace dresses. So that's the equation I'm working with down here. So I'm going to rewrite that right here. So I've got this. And all I'm going to do is plug in these values to see which I get the bigger value for. So I'm not even worried about this. I'm not going to make a very big profit right there if I make nothing. So I'm not going to even worry about that vertice, that point of intersection. So I'm going to plug in this. So where I see X, I'm going to plug in 0. So I'm going to take 318 times 0, which is 0. I'm going to take 270 times 4, which is 1,080. So my profit, if I did that, if I made 0 organza and 4 lace, I would be making 1,080. Okay, what if I plug in 5 for X? That would be 318 times 5, which is what? 1,590. Obviously if I plug in 0 there, I get 0. So there's my maximum profit for that one. My paper's moving here. Now, this is what I'm going to do. I'm going to plug in a 4 right here. If I plug in 4 for that and a 2 for that, use your calculator. Hit 318 times 4, 270 times 2, okay? But you get, that should be, use your calculator and check, I should get a profit of 1,812. That you can see is the biggest value, so that would be my maximum profit. So what does that tell me? Well, this is my X, and this is my Y. So remember way at the top, I let X, do you remember up here? I let X be my organzas. So that's saying to make the maximum profit of 1,812, I should make 4 organza dresses and 2 lace dresses. So that was my point of intersection, okay? And you can either find that by graphing, okay? Or by using whatever method you want to solve for these two, and then just plugging it into my equation. Hopefully that helps.